In this lesson, we are going to go over logarithm properties, and this is part 1. We have 2 objectives in this video. The first is to understand logarithms, or as you might see them written or hear me refer to them as just logs, and then our goal is to find logarithms. Okay, so first, logarithms. They come in the form of y equals log, you see the subscript a, and then x. So a is what's called the base of the logarithm. A must be greater than 0 and not equal to 1. So that means a can't be negative, can't be 0, and it can't be 1, and x has to be greater than 0. Okay, so there's a connection between logarithms and exponents. So if we have y equals log base a of x, we can write that as x is equal to a to the power of y. So notice here that this is the base, this is the exponent, and x is what it's equal to. And if we take a look at our logarithm, a to the y equals x. So this is actually how we will be able to convert between exponential and logarithmic equations, as well as evaluate logarithms. Okay, and if you look at this, a logarithm is actually the inverse of the exponential function. Okay, so example 1, convert to a logarithmic equation. So our form of a logarithmic equation is y equals log base a of x, and then as an exponent, it's a to the y equals x. So what we can do is we can line this up with the exponential equation that we're given. So 7 is our base. Sorry, my computer is doing something funny. Okay, so 7 is our base. 0.8654 is our exponent, and 5.387 is what it's equal to. So in order to write this as a log, 7 is playing the role of a, 0.8654 is y, and 5.387 is x. So we substitute those values in, and we have our logarithmic equation. So we'd have 0.8654 is equal to log base 7 of 5.387. Okay, and if you were to convert back to exponential, this would give us 7 to the power of 0.8654 is equal to 5.387, which is exactly what we started with. Next, so logarithms continued. So remember that if we have something like y equals 3 squared, 3 is our base, 2 is our power, and we're asked to evaluate. So in this scenario, given the base and the power, we are asked to evaluate. Now what we're given is we would have something like y equals log base 3 of 9. We'd be given actually the base and what it equals to, and we're being asked to find the power. So when we're finding logarithms, we're asked to find the power that the base is being raised to in order to get whatever's in this position here. Okay, so next, example 1, find the logarithm. So a is log base 10 of 100. So one thing you can do is we can set this equal to y. Remember that we are finding the power, okay? So if we write it, we go forward. So 10 to the power of y is equal to 100. So 10 to what power is equal to 100? 10 squared is equal to 100. So in this case, y would be equal to 2, or another way is that this logarithm is equal to 2, okay? And that's because 10 squared, oops, let me write that a little bit better. 10 squared is equal to 100, okay? Looking at part B, we have log base 4, 64, and we want to know what that is equal to. So I set it equal to y, and this allows me to convert it to an exponent. So I have 4 to the y is equal to 64, okay? And so we're finding 4 to what power is equal to 64. So if this is not something you know off the top of your head, 4 to the first is 4, 4 squared is 16, 4 cubed would be 4 times 4 times 4, which is 64. Okay, so in this case, y is equal to 3, and that's because 4 to the third is equal to 64, okay? So the final answer for this one is 3. The final answer for this one is 2. Example number 2, find the logarithm. So part A, we have log base 3 of 1, and we have this equal to y. So we have 3 to the power of y is equal to 1. Now, what could we raise 3 to in order to get to 1? Remember that anything to the 0 power is 1. So in this case, y is equal to 0. And that's because 3 to the 0 is 1. And that actually leads us to a property of logs that you may want to write down. We have log base a of 1, provided that a falls within the bounds that we talked about on the first slide, is going to be equal to 0. Okay. Part B, okay, so we have log base 2 of 1 over 8. Set that equal to y. So then we go forward. 2 to the y is equal to 1 over 8. Okay, so when we have fractions like this, it causes us to think about negative exponents. So for instance, 2 to the negative first is 1 over 2. 2 to the negative second is 1 over 2 squared, which is 1 over 4. And then you can keep going. 2 to the negative third is 1 over 2 cubed, which is 1 over 8. So in this case, y is negative 3. And y is allowed to be negative. That's okay. And that's because 2 to the negative third is 1 over 8. So the final answer for for B is 3, and then I'll circle it for A is 1. Okay. Example 3, find the logarithm. So we have A, log base 7 of 7, set it equal to y, convert it to an exponent. Now you may be able to determine what the power is equal to without converting it to an exponent. I just find it helpful, so that's what I'm showing. But if you already know what it's equal to by looking at it, you can do that as well. Okay. So we have 7 to the power of y is equal to 7. Okay, so 7 to what power gives us 7? That would be y equals 1. 7 to the first equals 7. Okay, so this leads us to another property that you may want to write down. Log base a of a is equal to 1. And then for part B, we'll set it equal to y. So notice 8 is our base, and 8 squared is what would play the role of x in our logarithm form. Okay, so we have 8 to the y is equal to 8 squared. Now for this, notice that in order for these to be equal, their exponents have to be equal because the base is the same. So 8 to some power equal to 8 squared, well, that power would have to be 2. So y equals 2. Okay, one way to demonstrate this is 8 squared is 64. So over here you might see that that's 2, but take note that when you have the same base, in order for them to be equal, their exponents have to be equal. Okay. And I believe this is written down as a specific property that we can write. Okay, this is on your formula sheet. Okay. But these ones that I've written down, if you know what the powers are doing, you don't necessarily have to memorize those. Okay. So let's talk about the natural logarithm. So the natural logarithm comes in the form of y equals ln of x. Remember previously we talked about e, so ln is the same thing as saying log base e, but you'll notice on your calculator has an ln button. Okay, it also has a log button. So the only two types of logs that your calculator can do are log base 10 and log base e, which is ln. Okay, so y equals ln of x. It works the same where if we say that this is log base e of x, this would be e to the y is equal to x. Okay, so it's actually the inverse of y equals e to the x, and so I've graphed them on the same coordinate plane. So the red line is e to the x. Oops, I should write that in red. And the blue line is ln of x. Okay, and you can see that it mirrors across the dotted line, which is y equals x, meaning it is the inverse. Okay. So example 1, find the value of the logarithm. So part A, we have ln of e. So we set this equal to y, and remember that our base is e. So when we go forward, this is e to the y, and it's equal to e. Oops. Okay. Again, we have the same base. We want their exponents to be equal. This is like having a 1 here. So in this case, y is equal to 1. For part B, we have ln of e to the 4th. So we set this equal to y. We have e, that's the base of the log. E to the y is equal to e to the 4th. The only way for these same bases to have an exponent and for them to be equal is for their exponents to be equal. So y is equal to 4. Okay. And for part C, we have ln of e to the negative 5th. Set this equal to y. The base of the natural logarithm is e. So the y equals e to the negative fifth. And again, these powers have to be equal. So y is equal to negative 5. Okay. Thank you for watching. If you have any questions, feel free to reach out to me.